All right. Hello, everybody. Happy 1 o'clock on a Friday or a cold, rainy Friday afternoon. We get to be inside electronically or physically talking about nomenclature. So nomenclature, we have added on 2 new functional groups for today, ethers and maybe, I guess, 3 functional groups, but ketones and aldehydes are similar in terms of the way that you name them. So those we will be going through today, but I want to remind you that everything we did last semester is still true. And you need to be able to still do all of that naming from last semester. You need to know how to name alkanes, alkenes, alkynes, alcohols, E and Z, RNS, all of that stereochemistry. I went through and graded all of the bridge assignments on Canvas if you turned them in more than 12 minutes ago. But if you have a whole lot of red on it, you're in good company. There were a lot of things that there's a lot of nitpicky stuff in nomenclature. So I tried to put relatively complicated molecules on the bridge so that it wasn't just simple examples in class and then the quiz was hard in comparison. So I tried to kind of put a little bit of everything on there so we were running into all of those things. That being said, before we get into the bridge, we're going to take a big step backwards and think holistically about nomenclature, and then we'll move back into the bridge. So this is nothing brand new, but I just kind of want to remind you of some stuff from last semester. So all of our naming starts with basically the word alkane, and then we modify it as we see fit. So if you know your carbon is, your molecule is 6 carbons long, how does that change the word alkane? Yeah, so basically the part that we change when we know how many carbons is just right here. So it's methane or ethane. What is 3? 3, 4 through 5 seem to be the easiest ones to forget. Prop, right, prop. What is 4 carbons? Bute, right, bute. And then pent, et cetera, oops, pent. But all of those become the beginning of the word of your main chain. All right, so if you have a double bond, an alkene, where does that go? Right. So the only things that replace the ane, specifically just the an, are an ene or an ine. And this is where, oops, undo that, just yn. So those things can fit into the name of the main chain. They just replace the an. So it could be propane or propene or propine. And that's where those things go. So when we get to other functional groups besides alkenes or alkynes, they're all going to replace the E at the end of the word. So we don't drop, if we have a ketone, we don't replace ane with one. Ane only gets replaced with ene or ine. It's just the E at the end that would get replaced with one. So think of those, the rest of the functional groups all just replace this E at the end of the word. The only one we did last semester was alcohols, which could become all. But how do we do aldehydes now? That's new for today. It's 2 letters for an aldehyde. Al, right. And what about ketone? Oh, right. For ethers, ethers are never going to be your highest priority functional group. So an ether will never show up in the name of your main chain. So whenever you start naming a molecule, to me, the most crucial part is finding the main chain. And that starts out with identifying the highest priority functional group. Because the main chain is not just the longest chain. The most important thing is it's a carbon chain that includes the highest priority functional group. And if possible, the second highest priority. And if possible, the third highest priority functional group. And once you've worked all of that out, then it's the longest chain that satisfies those criteria. So finding the highest priority functional group is going to be more important than finding a long chain. That being said, you need to be able to do both of those things. All right, but it starts with highest priority functional groups. All right, so this part right here, this E being replaced with all or al or own, you can only do that to one functional group. So if you have an aldehyde, the end of the word will be al, because that's our highest priority so far. If you have an aldehyde and an alcohol, it's not going to be prop all al. You're only going to have one of these at a time. So that will be the highest priority of them. What would happen to the second highest priority? Yeah, well, whatever it is, it would need to be a prefix. So then we would just treat it as a substituent, just like we would a methyl group or an ethyl group or something like that. So in terms of our priorities, our functional group priority at this moment, our highest one is what? Aldehyde, perfect. It is only going to be that way momentarily because on Monday, we will talk about a higher priority one. But if the aldehyde is highest priority, then it will be al at the end of the chain. If it's not highest priority, because you have a carboxylic acid, which will end up being higher, then it needs to be a prefix, which is going to be oxo. The same thing is true of ketone. If ketone is your highest priority, it's at the end of the name as an O. But if a ketone is not highest priority, right? So if we have an aldehyde and a ketone, the aldehyde would be highest priority, and it would have the al at the name of the main chain. Then a ketone, if that's also present, would have to be a substituent. And how do we know name ketones as substituents? It's also oxo. And because ketones and aldehydes are both just C double bond O's, it turns out that if they're substituents, it doesn't really matter. It's just a double bond O either way. All right, so what about alcohols? If it's the highest priority functional group, what do we do with it? How do we name it? It's just this. If it's highest priority, then it would be your all. Your highest priority functional group is gonna be in the name of the main chain. So if it's an aldehyde, it's a something something al. If it's ketone, it's something something O. If it's alcohol, it's something something all. But if it's a substituent, so it's not highest priority, how do we name an alcohol? Hydroxy, yes. And then it would end up, or it would go into the beginning of the name like a prefix, like a substituent. All right, so ethers are the other functional groups that we did. Ethers are at the very, very, very bottom of your priority list. And what that means is that an ether will never, ever, ever be your highest priority functional group. So it will never, ever, ever show up in the name of your main chain. Therefore, it will always be a substituent. It will always be a prefix, and it will be your alkoxy. It'll never be called alkoxy, but whatever alkyl group it is. So a 1-carbon ether would be a methoxy. 2-carbon would be ethoxy. All right, if it's 4 carbons, it would be butoxy. If it's 9, it's nonoxy, whatever it is with an oxy. You'll notice that the way we name an alcohol as a substituent, hydroxy, HO, this is alkoxy, so the alkyl and then the O. So those names end up being pretty similar. So for all of our functional groups, we need to think about how we can name them as both a substituent and as part of a main chain. The exception to that being alkenes and alkynes, because an alkene and an alkyne replaces a different part of the word in your main chain. So there is no conflict between an alkene and an alcohol. You may have an, I don't know, pent, ene, all, because they replace different parts of the words. So all of this priority stuff that we worry about, it's gonna be mainly focused on one of those oxygen or nitrogen containing functional groups. So for all of these, with 2 exceptions, you'll have to know how to name them as substituents and as main chains. The 2 exceptions are the ether, which is always a substituent because it's lowest priority, and carboxylic acid, which we'll cover on Monday, which is highest priority. So we'll never have it as a substituent. It's always the main chain. Everything else, it could be either one. All right. How you doing? All right. There is also stereochemistry that we talked about last semester. It may not be your favorite, but you still have to do it. E and Z always refers to an alkene. So if you have an alkene, you should look for E and Z. R and S always refers to chiral carbons. And if you see a wedge or a dash, you should consider that you might have to do R or S. All right, so let's use that information and jump into the bridge from today. Anybody have any questions before I skip on out of here? Okay. All we're going to do today is examples. So if any point you have a question, just stop me. It's absolutely fine. I would love to get to any questions you have, any examples that you want. Otherwise, I'm going to roll through examples, and that will be what we do. All right, so I am going to pull up the bridge. We will do a fresh one. All right, here we go. So that very first molecule has quite a few different things going on all at the same time. But we need to find our main chain first and foremost. And to do that, our first question to ourselves should really be, what's the highest priority functional group? So Mallory, what's the highest priority functional group in this molecule? Yes, the alcohol. So we are going to number a carbon chain. Main chain is always a carbon chain. So the carbon attached to the OH, this one right here, needs to be part of the main chain. What's our second highest priority functional group? The alkene. So if you can, those carbons also need to be part of your main chain. And then the only other functional group is that epoxy. And so one of these two carbons, either this one or that one, needs to be part of your main chain as well. Well, the good news is we can do that. We can just make this whole thing our main chain. And then we want the longest carbon chain that includes this one and this one and this one and this one, which would be going, of course, all the way to the end there. So this is going to be your main chain, this whole thing here. So your highest priority functional group impacts how you find the main chain, but also how you number the main chain. So quick reminder, we're only numbering carbons. We're doing our main chain. So where are we going to start? Right, so closest to the OH, which would be this one right here. All right. If you got two ends, if the alcohol were attached at this carbon, you would still go to the end of the molecule or the end of the chain, but it just happens to be coming off of one of those terminal carbons. So this would be 1, 2, 3, 4, 5, 6. So your name of your main chain should be what? Hexene-all, right? Because it's hex, it's 6 carbons long, and it has an alkene, and then it has the alcohol as your highest priority. Since you have two functional groups in that word, hex, the ene, and the all, you need to put the numbers inside of the word. So this would be hex 4, ene 1, all. All right, and at that point, we've captured most of our molecule. It's in this circle, circle-ish. So hex 4, ene 1, all hits the alcohol and the carbon chain and the alkene. So this is the only thing outside of it. So this is our only substituent on this molecule. So what is this thing? It's an ether. So with an ether, you have to treat it like something oxy. What do we call this chunk right here? Tert-butyl. So tert-butyl with an oxygen just becomes tert-butoxy. So methyl becomes methoxy, ethyl becomes ethoxy, butyl becomes butoxy. So tert-butyl becomes tert-butoxy, which seems maybe like a mouthful, but frankly, these are more made to be written than to be pronounced aloud. But we can. So this is 3 tert-butoxy, hex 4 ene 1 all. All right, so stereochemistry. 2 things to look for. A, do we have any wedges or dashes? No. Technically, this carbon right here, carbon number 3, is chiral because it has 4 different substituents. But if a wedge or a dash is not given you, you can't figure out whether it's whether it's R or S. So the assumption is that it's a 50-50 mixture of R and S, which is a racemic mixture, but you don't have to worry about it in terms of the name. We do, however, have a double bond. Excuse me. So with a double bond, we need to look for whether it is E or Z. And if you did not do that on your bridge assignment, don't feel bad because nobody did that on their bridge assignment. So we will all do it together and that will be fine. So quick refresher, when you are doing E and Z, you look at the 2 carbons in the alkene, so this one and this one, Draw in their hydrogens if they're not drawn already. So an H there, an H there. And for each of those carbons, you rank their substituents as 1 and 2. And it's the same way that we ranked 1, 2, 3, 4 for doing R and S. You go by atomic number, starting at the first directly attached atom, and then you keep going until you break ties. And if you never break ties, you don't have to worry about it. So here we have a carbon versus a hydrogen for the two substituents coming off of this carbon number 4. So carbon by atomic number would be higher priority than hydrogen. So this carbon up here would be our number 1 in terms of ranking. This hydrogen would be our number 2. So you should have, kind of as you draw a little dashy line down that alkene, something above and something below that line on each side. So 1 and 2 on carbon number 4. We have to repeat the same thing for carbon number 5. Once again, there's just a hydrogen and a carbon attached to carbon number 5. So down here would be 1, and up there would be 2. And then you look for whether or not those number 1s are together or apart. So here they're apart. One is above the line, the other one is below the line. They're basically as far apart as they can possibly get. So anybody remember, is that E or Z? No. Take another guess. Okay, yes, it's E, correct. So these were German words. Z is for zusammen, which is together. I always said it's on the same side as each other. But E is entgegen, it's apart, it's opposite. So there's distance between them, they are apart. And therefore this is E, and this would be E3 tert butoxy hex 4-ene 1-ol. That's a lot of stuff, but that's kind of how naming works. There's going to be a lot of stuff. A double bond that is Z might look like this. So this is 1, 2, 1, 2. Notice that here the 1s are together. So this would be what Z looks like, where your 1s are together on the same side of the atom. You're still ranking for each carbon 1 and 2, for each carbon 1 and 2. So you're never going to have both 1s over here, because for each side you're ranking things 1 and 2. Lastly, if you ever have something like this, whatever is on that side doesn't really matter. So let's go ahead and rank them here. Chlorine is 1, H is 2. But on this side, the H's are identical. So you can't rank them 1 and 2 because they're both the same. So therefore, this can exist, but it's neither E nor Z. It's just an alkene. You wouldn't have to include E or Z because it's neither. So it's not switched. It's not switchable. It doesn't matter. There aren't two versions of it. So this is E, this is Z, and this is just nothing. All right, questions on that? All right, that's my quick refresher on E's and Z's. All right, so let's move over to this one. I told you in the video that there's two different ways of naming epoxy compounds. You can either name them as the main chain like an oxirane, or you can name them as a substituent as an epoxy. It is far, far, far more common for you to name them as a substituent as an epoxy. If you were to name this as a substituted oxirane, then you would need to know how to name this whole thing with the alkene as a substituent, which is pretty complicated. Furthermore, your highest priority functional group is the alkene. So we should have the longest chain that includes that and the epoxy, which would go this way. So you can always name these things as epoxies. I would recommend that that's the way that you do them. Just name them as epoxies. I want you to be aware of the name oxirane. You'll see those come up sometimes, but it's usually when that's the only functional group in the molecule and everything else is pretty simple. So let's undo that. You guys did a good job on this one. The numbering was the only thing that kind of tripped some people up. But this is our highest priority functional group, the alkene. So we would want to include this carbon and this carbon in our main chain. Furthermore, the epoxy is in there. And so that functional group should be included in the main chain as well, if we can, which we can. So what our main chain would look like is this. This is the longest continuous carbon chain that includes all of your functional groups in the molecule. But where should we number from? The bottom or the left? The bottom. Why the bottom?
Because the alkene is the highest priority.
Right. Alkene's the highest priority functional group. So this would be a 1, 2, 3, 4, 5, 6. Don't forget that dashes and wedges are still just bonds, so they count as bonds, so those count as carbons. So it's a 6-carbon chain. I know that the examples I gave you were all 6-carbon main chains, but this is hexene is the name of this main chain, hexene. The alkene is at number 1, so you need to put 1 hexene or hex 1-ene. There may be something tickling the back of your brain saying, wait, I thought that if it was on number 1, we didn't need to include the number. That is not true in this case. It's only true in one specific instance, if you have a ring. If you have a ring, you do not need to include the number 1 for your highest priority functional group because rings don't have an end. So it doesn't matter really where you put it. You just say that it's at number 1. But anytime you have a chain, you need to include the numbers always, even if it's number 1. All right, so this would be for an alkene. So 1 hexene would be the name of that main chain. And then everything else is just a substituent. So what's this little CH3 called? Methyl. So there's a 3-methyl. And how do we do for this epoxy group? Epoxy, yeah. But we include both numbers. So 4, 5 epoxy. So that is our naming. We have a 3-methyl 4, 5 epoxy. Epoxy starts with E, so it would come first alphabetically. So 4, 5 epoxy. And then 3-methyl. And then 1 hexene. The only other consideration here is you do see that we have some dashes. So there is some stereochemistry to consider. There exists both relative stereochemistry and absolute stereochemistry. So we could go through and figure out whether carbon number 4 is R or S. However, if you have a ring, which this includes the oxiranes or cyclohexane or something like that. If both of your substituents are on a dash, we can say that they're cis to each other, which is relative stereochemistry because it's where they are relative to each other. So what we can do is just say that this one is cis. That's fine with me. This is how we did things for rings. It's been a while, but you might remember that if we had 2 substituents like that on this ring up here, we could say that that was trans. We could also technically go through and figure out whether they were RR or RS or SS or SR. But for my sake and the quizzes in this class, if you've got a ring and they're both on wedges, you just say cis. That's not true for a straight chain, but just for a ring. All right, questions on that one? All right, moving on down. So this was a pretty simple molecule. There's not a lot going on, but you do have 2 functional groups. So which is the higher priority of the 2 functional groups? Now go, which is higher priority? Nope. The other one, the ketone. So the ketone is higher priority functional groups. It turns out that priority is really ends up being based on the number of bonds to oxygen or nitrogen. And so carboxylic acid ends up being the top of the heap because it's 3 bonds to oxygen. This carbon that has 2 bonds to oxygen is going to beat the carbon that has 1 bond to oxygen when it comes to priority. So in case you were wondering about priority, that's generally how it goes. So the ketone is the higher priority of the 2 functional groups. So this carbon right here needs to be part of your main chain. Furthermore, if you can, the alcohol is the second highest priority functional group. So that carbon should be part of your main chain as well. You guys did a great job of this main chain. It's also pretty simple. It's just the 6 carbons right to left. So we would have this be our main chain, which would include the highest priority functional group, which is the ketone. The alcohol is second highest priority, so it needs to be considered a substituent. That's why I didn't circle it. All right, and if the ketone is higher priority, we should number from where? Left or right? Left, correct. So this would be 1, 2, 3, 4, 5, 6. So this would be a hexane-one. We do not drop the ane, so it doesn't become hexone. We drop the E at the end, so it's hexane-one. Or we replace the E at the end. So it is hexane-one, and we need to say where that ketone is. It's at number 2. So this would be a 2-hexanone or hexan 2-one if you wanted to embed that number in the middle. What am I missing? Yes. So when alcohol is highest priority, then it's something all. But when the alcohol is not highest priority, it must be treated as a substituent. And the way we do that is hydroxy. So this is a 4-hydroxy 2-hexanone. Right? But that carbon right there is chiral. So we need to go through and figure out whether this molecule is the R version or the S version. So we're switching up our colors. All right, so it's carbon number 4 is the chiral one. It has an oxygen on the wedge, it has a carbon over here on number 5, carbon number here on number 3, and then what we're missing but is present is a hydrogen. That must be on a dash. So don't forget the dashes and the wedges should be right next to each other in our 2-dimensional point of view. The oxygen is number 1, we can say that for sure. The hydrogen is number 4, we can say that for sure. And after one step to the right and the left, both of these are tied for carbon. So again, we spent some time on this last semester. I treated them like your children are tied. So you go one more step to your grandchildren. And you keep going generation after generation until you break the tie. If you never break the tie, it means they're identical, in which case it wasn't chiral in the first place. But after one step in each direction, it's just carbon. After 2 steps in each direction, it's just carbon. But on our 3rd step, over here, we would only have hydrogens. And our 3rd step over here, we would have 2 bonds to oxygen. And so the left side is going to be higher priority than the right side. So this is number 2, and this is number 3. So when you went through and did R and S, which I know it's been months since you did this, the first thing we do is we number them 1, 2, 3, 4. And then we want to rotate it all around so that number 4 is in the back. But number 4 is already in the back, so we don't have to do that. And then you draw an arrow from 1 to 2 to 3. And is it clockwise or counterclockwise? Counterclockwise. So this is S. So congratulations to the one person that got that chirality correct. If you didn't, you're in good company. It's okay. But that is something to include. If you see a wedge or a dash, you need to look for chirality. You need to look for whether it's R or S. I can guarantee you there will be some type of chirality, RS, EZ, or both on your quiz, because that is still a major part of nomenclature. You still need to be able to do it. All right. Any questions on any of those? Yes, sir.
So if 4 is in the front, how do we do it again?
All right. If 4 is in the front, you can do this kind of skippy thing where, you remember the song?
Yeah.
If 4 is in the front, you go 3 to 2 to 1. So you don't have to rotate it around. You just imagine yourself in the back. You draw your arrow 3 to 2 to 1 instead. Okay. If your number 4 is on a line, so on the side, then you have to rotate it, like physically or mentally rotate it around so that it's in the back. It's not going to work spinning your paper, but you can spin your head if you want to, and you can make that work. All right, the last question here, I did put a little tiny bit of chemistry into this, which is that in aqueous solution, ketones and aldehydes will turn into hydrates. It's a completely reversible reaction, but they end up looking like a geminal diol is a word for it, but 2 OHs on the exact same carbon. So this molecule right here in the carbonyl would turn into 2 OHs at the same time. And this whole thing would exist in equilibria. So if you ever had this molecule in solvent, aqueous solvent, it would be mostly the ketone, but there would be a certain percentage that would always be in this little hydrate. So that's just something that happens. If you ever have formaldehyde, there's a good amount of the hydrate in there in solution. Aldehydes more often than ketones, but it's just something that happens with ketones and aldehydes. It's not a big reaction. It's just something to be aware of. All right. So we have 31 minutes. I'm just going to give you examples, and we're all going to name them. Are you ready? All right. So we're going to close this bridge down. Go back to Zoom. Share a whiteboard. And I'm going to draw you guys some molecules. All right, let's start with that one right there. All right, so take about, I don't know, 4 minutes. But start with the question to yourself of what is the highest priority functional group? And then what is the second highest priority functional group, et cetera, et cetera, et cetera. And find the main chain before you try to tackle everything. If you have any questions, just ask. What's your highest priority? What's your second highest priority? Yes. Yes, because if you want to include, if possible, all of your functional groups. Otherwise, it gets really hard to do that. Okay, that's good. All right. So what's the longest carbon chain that includes those carbons? No. So you need to include the ally? Yeah, there you go. We're good. All right, so let's talk through this one together. First question, what's your highest priority functional group? Yesenia, what's your highest priority functional group? Yes, so this carbon needs to be part of the main chain. What's your second highest priority functional group? the ketone. So if possible, this carbon right here must also be part of your main chain. And that's all of our functional groups. And we can include both of those carbons. So now we worry about the longest carbon chain. We want the longest carbon chain that includes both of those carbons. So this will not be the longest carbon chain in the molecule, but it's the longest one that includes both of those. So we want to include this one and this one, but remember that the aldehyde is our highest priority. So that's going to be in the name of the main chain and the ketone is not. All right, we're going to start numbering, right or bottom? Right, why?
Because the aldehyde's higher priority.
Correct, aldehyde's higher priority. So this would be 1, 2, 3, 4, 5. All right, Letitia, how do you name that thing as a main chain? Yes, perfect, pentanal. We do not include a 1 because an aldehyde is always at the end. So it's just pentanal. All right, so now we need to include the substituents and we will be done. How do we name this thing, a double bond O of a ketone, as a substituent? Yes, perfect, 4-oxo. And then it's been a while, but this is one of your special butyl groups.
It's not sec.
It is not sec-butyl. For sec-butyl, this carbon right here, the one directly attached, would be secondary. So it's split there. Whenever we have a split end at the very end, isopropyl would be if it was 3 carbons, but this is 4 carbons, 1, 2, 3, 4. So
Sec-butyl.
Isobutyl. So isopropyl is a split end on 3 carbons. Isobutyl is a split end on 4 carbons. I didn't ask you to name this, but isopentyl would be a split end on 5. Isooctyl is a split end on 8, but iso is always going to be the little split end. So this is isobutyl, which gets alphabetized under I. Not that it matters in this case, but this is a 3-isobutyl. And putting those things together, the isobutyl would come first. So 3-isobutyl, 4-oxo. There should not be a dash in there, I guess, because it runs together as all letters. 4-oxopentanal, and that's everything. Questions on that one? All right, this one is going to look weird. Do what we've been doing, find the main chain. Name the main chain, and then everything else is just a substituent. Are you ready? Mallory, what is the highest priority function group in this molecule? Correct. So this carbon right here needs to be part of your main chain. What is your second highest priority function group? The ether. So this is an ether, carbon, oxygen, carbon. So one of those two carbons there needs to be part of your main chain, but you know that this one does for sure. So the longest one that includes this one, the only chain that includes that one, would be this right here. I think that if you find or circle that main chain, the rest of this becomes a little bit simple, but it looks really weird at first, I think, because there's a tendency to look at a long chain and try to include all the carbons in the main chain. But don't forget, the main chain is going to be a continuous chain of carbons. And so if you were to have an oxygen in the middle, it's no longer a continuous chain of carbon. So this is your main chain. So what's this called, Mallory? Yep, 1-butanol. And then this is 1, 2, 3, 4. So what is the name of this substituent at position number 4? So something oxy. Close. So it's just propoxy. So this is a 4-propoxy, 1-butanol, and that's it. 4-propoxy, 1-butanol. Any questions on that one? All right, good. So we are going to work through this next one together because you have, I think you could work your way toward how to do this, but I have not specifically told you how to do it, so we'll do this as a group. All right, so what is your highest priority functional group? Yes, the ketones, and there's 2 of them. So both of these ketones should be, if possible, which it is, part of your main chain. So your main chain will be the longest continuous carbon chain that includes those 2 carbons. How long is it? 7. You cannot ever have a main chain that goes back and forth between a ring and a straight chain. It either needs to be one or the other. And so this carbon right here is going to be the end of your straight chain. So therefore that will be the end of the main chain. So this is your main chain right here, which includes 2 ketones. Okay, if you had 2 methyl groups, how would you name it? Dimethyl. If you had 2 methoxy groups, you would call it what? Dimethoxy. If you had 2 alcohols, one alcohol is something all, 2 of them would be diol. If you have 2 ketones, it would be, follow the pattern?
Dione.
Dione, yes. So this is a 7-carbon chain. If it was just 1 ketone, it would be heptanone. But because there's 2 ketones, it's heptanedione. It's not diheptanone because you don't have 2 heptanes. You have 2 ketones, so it's heptanedione. So the name of this main chain here would be heptane. And usually we chop off the E at the end and replace it. But because doing so would leave us with multiple consonants in a row, kind of looking like heptanedione, we just leave the E there and just make it heptanedione. So that's how you do 2 ketones. It's just dione. You need to include their numbers. So we need to go through and number this chain. Should we number from the right side or the left side? Why the right? It is closer to one of the ketones, correct. If you went from the left side, the ketones would be at 3 and 6. If you go from the right side, the ketones are at 2 and 5. When you number for the highest priority functional groups. So while this thing is closest to the left side, this is not highest priority. So that would only be used in case of tie breaks. But we don't have a tie, so we don't have to worry about it. So 1, 2, 3, 4, 5, 6, 7. So our dione is a 2,5 heptane dione. Everybody good with that for a main chain? All right. So this thing as a substituent. First off, what is this thing? Cyclohexane, yes. So methane is a 1-carbon chain. Methane as a substituent is methyl. Hexane is 6 carbons. What's hex as a substituent? Methane is to methyl, as hexane is to hexyl, as cyclohexane is to cyclohexyl. So as a substituent, this is a cyclohexyl. So we have a 7-cyclohexyl.
Dr. Ring,
Yes.
if there was an alkene present on the main chain, would you have to put like hept1-ene-2,5-diol or something?
Yes. So if you guys did not hear that question, if you also had an alkene, anytime you've got an ene and another functional group, you have to include all of the numbers in the middle. So the 2 and the 5 would go in front of the dione, and then whatever number for your alkene would go in front of the ene. Yes.
Okay, thank you.
You're welcome. So that is it. Do I have any wedges and dashes? Mercifully, no. So I don't have any R in the S. Do I have any double bonds? Well, I have C double bond O's, but I don't have any alkenes, so I don't have any E's or Z's to worry about. And so that's it. We can do it. We can do it. You should practice this, but you knew that anyway. All right, let's keep going because we've got 14 more minutes. All right. All right, I'm going to give you a couple minutes on this one, and then we will go through it together. Don't forget, find the highest priority functional group first, find the second highest priority, et cetera, et cetera, et cetera. Set up your main chain before you try to do anything else. Cool. Carbon's the alcohol. The alcohol is not attached to the fire. That's the one. So the dash. The dash is a bond to a carbon, and then it's another bond to a carbon. No, so which, that's an alcohol. Or a carbon is the alcohol. Yeah. That carbon right there. So that carbon is the carbon. right, for those of you out in Zoom, don't forget that this right here is a carbon. These are all carbons. So it is a little bit weird with the dash, but the dash is still just a bond. And it ends at the end of the dash, and then there's another bond to the O. If you haven't given its full attention, there is a dash here. And if you see a wedge or a dash, you should be looking for chirality. All right, we'll do this in one more minute. R, the way they thought, yeah, and then S is the O. Okay, so the highest priority functional group is what? You're all whispering aldehyde to me right now, and that is correct. It is the aldehyde. So we know that this carbon right here needs to be part of the main chain. The second highest priority functional group, or the only other one, is the alcohol. And so the carbon to which the alcohol is attached, that one, also should be part of your main chain. So your main chain should include both of those carbons. So much like on the previous page, we had an example. This is not the longest carbon chain in the molecule, but it's the longest carbon chain that is attached to all of your functional groups. So the aldehyde is the one that is the highest priority and is included in the name of the main chain, but we do have a main chain to which that alcohol is attached. When we number this, we should number from the side closest to the highest priority functional group, which is the left side. So 1, 2, 3, 4, 5. So the name of your main chain would be pentanal. And you don't have to put a 1 because the aldehyde will, of course, be at number 1. There are not very many functional groups that have to be at the end of the chain. Aldehyde and carboxylic acids are pretty much it. Okay, so the alcohol is on number 5. So that would be called what? Chloe, go. 5-hydroxy? I couldn't tell what you said. Oh, oxo. So oxo is a double bond O. So if the aldehyde was a substituent, it would be oxo. But with an alcohol that's a substituent, it's hydroxy. Kind of like HO, hydroxy. And what is this thing right here? Yes, propyl. So we got hydroxy on 5, propyl on 4. Hydroxy comes first alphabetically. So 5-hydroxy, 4, oh dear, propyl pentanal. And we do have a dash, and we do have a chiral carbon right there. That carbon number 4 is chiral. So let's do this in a different color. We will have a wedge to a hydrogen that isn't drawn. That will be your number 4. And then we are looking at, here we have a carbon and then an O. Here we have a carbon and then a carbon and then a carbon. To the left, we have carbon and then carbon and then carbon and then oxygen. So the top is going to be your number 1 because it gets to the oxygen first. The left is going to be your number 2. It's going to get to that oxygen second. And then the right side is just carbons, and that's going to be your number 3. So we could do that individually walking down, but that's the conclusion you guys would get to. All right. So at this point, you have a choice. Number 4 is not in the back. So either you can rotate it around to put number 4 in the back, or 4 is in the front. Just go ahead and go 3 to 2 to 1. So I'll draw my arrow from 3 to 2 to 1. That would be how the clock moves. Yes. So R. So this is R, 5-hydroxy, 4-propyl pentanal. Ta-da. All right, real quick, there is one more skill that you will have to do on a quiz. But I find that students tend to have most trouble given a structure and coming up with a name. That is a harder skill and one that I think needs more practice. But the other way is also true. You're given a name to be able to draw a molecule. So I'm going to give you one name real quick and we will be done for today. We're going to go with 4-isopropoxy 2-cyclohexenone. All right, this is a lot. Don't try to tackle it all at once. My advice to you last semester is the same as this semester. Draw your main chain, number it, and then just fill stuff in. So here we're looking at a cyclohex. Start with that. And that should give you 6 carbons in a ring. And then just go ahead and number them. And it doesn't matter with a ring where you number. So Miguel, where would you like to start numbering? Great. And do you want to go clockwise or counterclockwise? Great. All right. So we need to fill things in. If you got an ene and an one, which one is showing up at number 1? It's the highest priority one. Yeah, the ketone. So the ketone should be at number 1. That's what one means. And what's at number 2? Yeah, so the alkene starts at number 2. So it should be an alkene from 2 to what? 3. Yep. And then the only other thing remaining is a 4-isopropoxy. So what do you think an isopropoxy is?
Isopropyl and double bond oxygen.
Not a double bond oxygen. This is how we name ethers. So it's just an isopropyl and then what?
The oxygen.
Yeah, just an oxygen. So methoxy was a CH3 and then an O and then your chain. Ethoxy would be 2 carbons and then an O and then your chain. So isopropoxy is an isopropyl and then an O and then your chain. So it would look like this. Doop, 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 doop. Oh no, I put it at number 5. Hold on. Ah. There we go. That's better. All right. So trying to draw this all at once can be incredibly overwhelming, but just draw the main chain first and then number it and then attach the stuff. And you can do it. All right. Any last minute questions? Thank you all. I hope you feel a little better about this than you did when you looked at your bridge feedback. Please practice this. On Monday, we're going to do 2 more functional groups, but amines tend to be the straw that broke the camel's back sometimes when it comes to layers of nomenclature. So please try to get these down. And so we're just fighting against those 2 things. Thank you very much. I will see you on Monday or Tuesday. Yep.